Hello everyone. What I'd like to do in this video is talk about the minimum and maximum values of a quadratic and then derive a general formula for the vertex of a parabola so we don't always have to be putting things into vertex form. Okay, so remember a quadratic f of x is equal to ax squared plus bx plus c, and what we've been doing is trying to massage this form to make it look like a times x minus h squared plus k. So if you have the question, these a's are the same here. Okay, so we have really two different situations. One, if we have a is positive. So also a thing to note, remember when we have this in vertex form, the vertex is at h and k. So h and k. And remember, if if a is positive, this will be a happy face parabola. It's a positive happy face parabola. So the graph will look like this. Recall that if a is negative, then it'll be a frowny face parabola. Very sad parabola. So for these two parabolas, notice for a happy face parabola, its vertex will be the minimum value. Be the minimum. And for a frowny face parabola, the vertex will be the maximum value. So if we're looking for the minimum and maximum of a parabola, what we're doing is we're looking for the vertex. Okay, so let's derive a general formula for the vertex so we don't always have to be completing the square and writing it in this form. Okay, so how are we going to do that? What we're going to do is I'm going to go ahead and I'm going to write this general quadratic into this form so I can figure out what h would be and what k would be. What I'm going to do is I'm going to scoot this one over here. So f of x, let's see, is that glare getting us? No, we're okay. Equal to a times x minus h squared plus k. Okay, so how are we going to do that? We're going to do it just like how we did any of them. We're going to group our first two terms together. So I'll write that as f of x is equal to, now remember when we're completing the square, we want the coefficient in front of x squared to be a 1, so I need to factor out this a. So in parentheses, we'll factor out the a. And I'll be left with an x squared. Now, how do I factor an a out of the b? Well, the way I like to think about it is if I were to distribute this a back into the parentheses, I would have to make sure I get b back. So what I think I will need to write here is a b over ax. So notice as this a distributes back in, the a's would cancel and I'd be back with b. Okay, plus c. Now let's leave ourselves a little bit of room here. Or how about, let's do this and do the next step. So here we have f of x is going to be equal to, we have our a, parentheses, x squared plus b over ax. We still have that plus c. Let's kind of just put this in a box. You see it's kind of grouped over inside. Okay. So what do I want to add here to make this factor to a perfect square? Well, I want to take the coefficient in front of x. I want to take that b over a, and I want to cut it in half. Now, because I have a fraction here, by cutting something in half or dividing by 2, an equivalent way to do that is dividing by 2 is equivalent to multiplying by a half. So if I'm dividing this by 2, that's equivalent to multiplying by a half. So I want to take half of b over a and I want to square that. Or if I multiply the fractions, this will be b over 2a quantity squared. And that's what I want to add here. So I want to add, we'll write that in green, I want to add a b over 2a squared. But if I'm adding a b over 2a squared inside the parentheses, I need to subtract that. But be careful, what I really added was an a times a b over 2a quantity squared. So I need to subtract an a times a b over 2a quantity squared. Okay? So let's see how this will factor. This will be f of x, which is equal to a. This will now factor to x plus a b over 2a quantity squared plus, what are we going to get? We're going to get a c minus an a. Okay, so I'm going to distribute the square into the parentheses. I'm going to get a b squared all over 2a squared. 2a squared will be a 4a squared, so I've just squared what's in the parentheses. Now notice that the a's cancel, or one copy of those a's cancel. So I'm left with f of x is equal to a times x plus b over 2a squared plus, what are we going to get here? ac minus, what are we going to have here? We'll have a b squared all over 4a, since one of those a's canceled. Okay, so let's go ahead and write it like this. F of x is going to be equal to an a times an x. A positive is the same thing as a double negative. So how about we're subtracting a negative b over 2a squared plus, how about I put in parentheses here, the c minus b squared all over 4a. So now if we're matching everything up here, I put this in parentheses, well, x minus h, that means that this must be our h, and this must be our k. So we now have a general form, or general formula for the vertex. The vertex of a parabola is negative b over 2a for the x-coordinate, and a c minus b squared all over 4a. Okay, do I have this memorized? No, I do not. I do have memorized the x-coordinate. I do know that the x-coordinate of the vertex is negative b over 2a. Do I remember the c minus b squared over 4a junk? No, I do not memorize that. I remember that the x-coordinate for the vertex is negative b over 2a. If I want to know what the y-coordinate is, I just plug that back into our function to figure out what the output is. So what I would really like us to take away from this is that the x-coordinate of the vertex is x equals negative b over 2a. Beautiful. I'll see you in the next video. Take care.